Hello everyone, welcome back to mahafarkar.co.in. In this article, we are going to learn about spectrum of black body radiation. Before that, just recall the structure of black body. We know that the body which absorbs maximum amount of heat incident on it is called as what? Black body. The aperture made in the structure of the black body plays very vital role for absorption of heat. Okay. Now, two different people, Prinsham and Lumer, two persons have studied the energy emitted by black body at different temperatures and the wavelength. They plotted the graph between energy and wavelength, and what they have observed they have recorded, and this structure we consider as what? Spectrum of black body radiation. Here spectrum word will be in simple words that he drawn the graph of energy versus wavelength, and he got some values of wavelength where he found some maximum energies. So what he observed, in short, we are going to learn. So what is happened? Suppose there is a constant value of temperature. Say certain temperature, at certain temperature. Say temperature is 1200 Kelvin, 1200 degree Kelvin. So what you observe that as wavelength of radiation increases, as wavelength of emission is increases, initially energy increases, or I can write it in opposite manner. Initially, when energy increases along y-axis, wavelength also increases and then it decreases. So as you can see from the graph that initially energy is increased, correspondingly wavelength is also increased up to certain point, and then now wavelength goes on decreases. Now if I increase the further temperature, suppose temperature is now 1400 degree Kelvin, then what is observed again? That again energy increases, wavelength also increases and again decreases. But now if I compare the wavelength at 1200 degree Kelvin and the wavelength at 1400 degree Kelvin, what is the important difference? That the maximum value of energy for both the wavelength is occurred, but for E1 corresponding wavelength was lambda 1, for E2 corresponding wavelength was what? Lambda 2. So lambda 1 and lambda 2 are the wavelengths where energy was a maximum, energy is a maximum. They are wavelength is not maximum, remember, wavelength is not maximum, it is the value of wavelength for which energy is maximum. So what they suggested that according to this structure, the wavelength and energy are related such that if value of energy increases or value of emitted energy by black body increases, the value of wavelength goes on what? Decreases. So from graph we can easily say that the maximum value of energy is increasing along y-axis, the wavelength for which that energy is maximum is shifting towards the left, that is towards the origin. Okay, so if I consider all those curves, then peak points of all those curves are shifted towards the left side, and that was the important observation made by Prinsham and Lumer. So they suggested that initially energy increases, wavelength also increases, and then the energy is maximum for certain wavelength. We call that wavelength as well lambda max. Remember, lambda max doesn't stand for maximum value of wavelength. It is the wavelength for which energy is maximum. So as temperature increases, the peak of curves shifts towards left. Means lambda 1 is less than, is greater than lambda 2, which is greater than lambda 3, but E1 is less than E2, which is less than again what? E3. Okay. These assumptions were again studied by Sir Vance, and he gave rise one law called as Vance displacement law. Vance displacement law. What he has observed, then we already learned that the wavelength for which energy is maximum at given temperature, or the maximum value of wavelength, is inversely proportional to the temperature. As temperature increases, the peak of curve shifts towards the left. That means the wavelength for which energy is a maximum, energy is what? Maximum, is inversely proportional to the absolute temperature of black body. Okay, so I can write this verbal form as lambda max is inversely proportional to T, or lambda max is equals to B into 1 upon T, where B is a constant, and that constant here is called as Vance constant. So from this equation I can get B equal to lambda max into T. Okay, so constant, its value is 2.93 into 10 raised to minus 3 meter Kelvin. So this was the spectrum of black body radiation. It was the observation done by two people, that is Primsham and Loomer. What they have observed is that at particular value of temperature, energy is increased along with the wavelength for some instant, and then again it goes on decreasing. The value of wavelength for which energy is maximum, if decreases if the temperature is increases. Okay, this was the important observations which were done by Primsham and Loomer, and that observation in the form of graph are called as spectrum of black body radiation. I hope you understood this article. Thanks for watching mahasarkar.co.in. Have a nice day. Thank you.